Hello everyone, welcome to this session on Kubernetes interview question. Kubernetes is one of the most important container orchestration tool these days, and it has basically surpassed the usage of Docker Swarm from back in the day. Every company which is operating on the microservices architecture these days is making use of Kubernetes for all the containers that they have to launch. So today in this session, we will be discussing some of the most important interview questions that can be asked to you in your next DevOps interview. So let's get started.
Hi guys, and welcome to this session on Kubernetes interview questions by Intellipaat. So Kubernetes is one of the most in-demand skills in a DevOps engineer and for many different kinds of software developers for that matter. Most of the organizations today are using different kinds of containers for running their microservices, and the orchestration of those containers or those Docker containers are done through Kubernetes. So Kubernetes is a very integral part of the architecture of a lot of organizations. That's why it is very important that you learn this thing inside out and you have good zest of about how things work. So today we have decided to come up with some interview questions, around 20-21 questions for you, so that you can get a better handle of things and get ahead of the curve, remind yourselves of the important concepts. And my advice would be go through these questions. After that, you'd know which topics you might be lagging in and just revise those concepts, revise those questions really quickly. And I think that will be getting you ready for that interview tomorrow. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. Also guys, if you do like the video, give it a thumbs up. Now, let me give you a guide of how the questions are. Some questions are pretty basic. These questions are generally asked just to, ease you into the conversation when you're ever going to an interview. So a basic question like what is Kubernetes, or what do you know about pods and these things. These are the questions which are there to, ease you into the conversations and then build it from there. So when you talk about, for example, if they ask you about what is Kubernetes, and then they will build you on okay, you told me what is Kubernetes, tell me about the architecture, and then they'll pinpoint one particular component of the architecture and ask you questions on that, like etcd or something like that. So that is how generally these interview go about. Other thing to keep in mind is these questions that we have today, some are very basic, some are intermediate concepts, and some are scenario based, so it gives you a better understanding of what you will be up against in the interview. So without wasting any further time, let's begin. The first one is the most basic question. This is generally used to ease you into the conversation. So whenever you write Kubernetes in your resume and you're a beginner for that matter, people ask you like, okay, what is your understanding of Kubernetes? Like, what do you mean? What is Kubernetes? So the good answer to this question would be Kubernetes is a container orchestrating tool that is used to automating tasks of managing, monitoring, scaling, and deploying containerized applications. Now, you can have a group of containers which can be logically discovered, and majorly Kubernetes is used because when you host your applications on Kubernetes, and let's say if you're going for some updates, in that scenario, you will not have a downtime. There's a feature in Kubernetes which allows you to have less or zero amount of downtime for your application. Other than that, Kubernetes has very great functionalities like self-healing capabilities, auto scaling, and different things like that, which makes it very good. When compared with other container orchestrating tools, it is very much more secure, and that's why Kubernetes is preferred in the industry. And through this question, they may ask you a few questions like, what do you mean by a container? What do you mean by a microservice? What is a monolithic service? So if you are looking for answer of these, just check them out really quickly if you don't know the answers to these questions. And from this one, let's move on to the next question. Next question is, when you mention Kubernetes is a container orchestrating tool, so they will ask you, is Kubernetes the only container orchestrating tool, or they will ask about containers. And whenever you talk about containers, Docker is the number one container, right? Number one tool for making containers. So Docker is extensively used across almost all the organizations to create containers. Now people will ask you, why not use Docker Swarm, right? Docker Swarm can also do container orchestration, so why go for Kubernetes rather than Docker Swarm? And this is where the differences between Kubernetes and Docker Swarm kick in. So basically you should know that a Docker Swarm is a default container orchestrating tool that comes with Docker. Docker Swarm can only orchestrate simple Docker containers, and whereas if you talk about Kubernetes, you can handle much more complex software applications environments. The few things which gives Kubernetes an edge over Docker are like Docker Swarm cannot do auto scaling, whereas Kubernetes can. Kubernetes can do auto scaling for your applications. So let's say if there are certain times, let's say if you are hosting an e-commerce applications, right? So there are some times of the year where you have much more traffic than the others, and whenever you're hosting some kind of sale, the traffic would be more than usual. In those scenarios, what you would require is a scaled up and version of your application so that it can handle the traffic. Docker Swarm cannot deal with that, whereas Kubernetes can. So that's why people prefer Kubernetes, number one. Second, Docker Swarm doesn't have a GUI, whereas Kubernetes provides you with dashboards. Although a lot of people do prefer the dashboards, but mainly people go for something like a Prometheus or a Grafana for the monitoring, as well as they look into logs and different things like that. So it is something which is useful, but not that extensively used. But as a defense, you can give, like, people prefer having dashboards, and Docker Swarm doesn't provide them with one, whereas Kubernetes does. That's why people prefer Kubernetes. The third thing you can say is the Docker can deploy rolling updates but cannot deploy automatic rollbacks. So what happens is, let's say whenever you're hosting in some new version of your updated application, right? So Docker Swarm can roll your updates without it can do rolling updates for your application. But let's say the application that you hosted, the version 2.0, it was having some bugs. It was not able to work function properly. Now when you want to roll back to the previous version, Docker Swarm does not have that capability to scale you down for the automatic rollback, but Kubernetes does. Kubernetes provides you with the functionality where you can do automatic rollbacks, and that is one of the greatest features which is out there. So if your application has some kinds of problem, you can roll back really quickly, and that is something which is desired by almost every developer which is out there, right? Because writing a perfect code is important, but not always achievable. There will be bugs here and there, and in those scenarios what you would need is automatic rollbacks, right? There are few other things that you should also keep in mind when you are comparing Docker Swarm and Kubernetes. Like, Docker requires third-party ELK stacks for logging and monitoring, while Kubernetes has some integrated tools as well. But I would see that whenever you mention this, just mention that although this is the case, a lot of people prefer different kinds of monitoring tools like Prometheus, Grafana, and there are a lot of different things like that. And you should tell them out that you have knowledge about this, because that gives you a little bit of the edge. Other than that, Docker Swarm can share storage volume with any container easily, whereas Kubernetes can only store storage volumes with the containers which are in the same pod. So if you have a pod which is like two different pods, they cannot share the information. But if you have two containers inside of the same pod, then they can share that volume mount. Whereas the difference between Docker Swarm is it can share the volumes between the two containers very easily. So these are the differences between Kubernetes and Docker Swarm. You can use this based on your questions. Whatever the question is being asked, like which is better and whatnot, you can choose some points from here and there, and you can leverage itself and get yourself ready for that question. Let's move on to the next question.
Alright guys, so if you like the lecture so far, we also train on Kubernetes, and it's a complete online training. For more details, you can check out the details on the screen. That will lead you to our training page where you can check out what all we teach in our Kubernetes course.
Which is, what is a Heapster? So Heapster is something which lets us do cluster monitoring, container cluster monitoring. It lets you basically do cluster wide monitoring and event data aggregation as well. So, and it has a native support for Kubernetes. Always mention that it has a native support for Kubernetes, and it is used for cluster monitoring. So this is an important questions when it comes to monitoring. We were talking about in the last one, right, that Docker has to depend on ELK, whereas Kubernetes have native supports for a lot of different things like Heapster and whatnot. And that's somewhat why it is important to know about Heapster. Let's move on to the next question, which is talking about a Kubernetes architecture point. What is a kubelet? So Kubelet is a service agent that controls and maintains a set of pods by watching for pod specs through the Kubernetes API servers. What is a pod spec? Pod spec basically refers to pod specifications, where you tell them what the pod is all about, what is the image that it is pulling, what are the arguments to be passed, and different kinds of things with respect to what the pod should have, like the replicas and different things like that, all the specifications of the pod. So it's the job of the kubelet that controls and maintains the set of pods by looking at those specifications, and it gets that from Kubernetes API servers. It also preserves the pod lifecycle by ensuring that given set of containers are running as they should be. Right? It makes sure that if, let's say, one of the containers or one of the pods is not functioning properly, it is its job to make sure that it's running properly. If it doesn't, it has to do something about it, right? Kubelet runs on each of the node which you have. So you have in the architecture, when we'll discuss sometime later in the questions, you have basically two different components in Kubernetes architecture. There is master components and there are node components, right? Two major ones. So in master you have different set of things running, and in the node section you have different things of set of runnings. So in each node you have a kubelet that runs, and it enables communication between the master and the slave nodes. So that is another job of kubelet. That is what a kubelet is. When you talk about kubelet, you cannot let go of the another important thing, which is what is kubectl. So kubectl is again a very important component. You basically interact with it to use it to interact it with your cluster. So kubectl is basically a Kubernetes command line tool that is used for deploying and managing applications on Kubernetes. Kubectl is useful for inspecting the cluster resources, for creating, updating, deleting components. So basically any interactions that you do with your cluster, you do it through kubectl. And whenever you want to, let's say, know how many pods are running, or which pods are running in which namespace, you want to create pods, you want to delete pods, you want to do automated updates, anything with respect to that, it is done with the help of kubectl. So you write the commands as kubectl and then get pods or create f in the file name and different things like that, right? So kubectl is the command line tool which is used for basically interacting with the cluster. So with that, let's move to the next one. What is the different services within Kubernetes? So in here you would be expected to talk about different services as well. So you have different kinds of services in here in Kubernetes. So basically we have 4 kinds of services in Kubernetes. So these 4 types of services are cluster IP service, the node port service, the external name, and the load balancer. Let's talk about all of these services really quickly. So the cluster IP service is the default type of service. Whenever you create a service and you do not give specification of what it would be, what kind of service it is, then by default it creates a cluster IP kind of service, and you can reach this kind of service only internally within the cluster. It is not exposed to the outside world. So let's say if you want to see it on your web browser, that is not going to happen, because it is something which is created for internal interaction of inside of the cluster. It is not exposed outside anywhere. You cannot reach the service externally. If you want to go for externally reachable service, you have to go for some other kind of service. Then the next type of service is node port type of service. This type of service basically exposes the service on each node's IP at a static port. So you define a port, and on that static port you can expose your services there. A cluster IP service is created automatically, and a node port service will route to it. Basically it's done like that. From outside the cluster, you can contact the node port service by using the node port IP and the port. You can use IP and in the port name you can interact with that, right? If you want to access the node port service. Then there is a load balancer service. This kind of the service basically exposes the service externally using the load balancer of your cloud provider. So whatever the cloud provider you are using, it will use the load balancer of that cloud, and it will expose the service externally. Now, external load balancer basically routes your node port and the cluster IP service, which are created automatically. That is in behind what happens. Generally speaking, when you are talking about load balancer services, you just need to mention that this is the kind of the service which exposes your service with the help taking the help of the load balancer of the cloud provider that you are using, right? That has to be mentioned, of the cloud provider that you are using. Now, the final services that we are going to be talking about is the external name service. Now, this type of service basically maps the service to the contents of the external name field. For example, www.intellipaat.example.com. It does this by returning the name of the value for CNAME record, right? So that is what these services are. So there are 4 kinds of services. If you are asked, cluster IP is the internal kind of communicating service. If you want to expose, you can use node port or load balancer service, and there is another service which you can use, which is the external names, right? So these are the 4 services. Let's move on to the next question. Now this is to ask about how to set a static IP for Kubernetes load balancer. So Kubernetes master basically assigns a new IP address. So we can set a static IP for Kubernetes load balancer by changing the DNS records whenever the Kubernetes master assigns a new IP address. So whenever it is assigning a new IP address, you can basically change the DNS records, and with the help of that, you can set a static IP for your Kubernetes load balancer. So it is a bit of an intermediate question asking about how to set a static IP for a load balancer. Let's move on to the next question, which is what is etcd? So again, very core question asked in about almost all of the interviews for beginner levels with respect to the architecture. Etcd is a very important component of the architecture. So etcd is basically a distributed key value store for all of the data, including the metadata, configuration data, and everything else. All of the information is there in these etcd, and it is stored as a key value pair. It allows the nodes in the cluster to read and write data, and etcd represents the state of a cluster at a specific moment in time, and it is the center for the management for cluster coordination in Kubernetes, right? So for management and the cluster coordination, etcd comes into the picture. It represents the state of the cluster at a given moment of time. It stores all of the information, including the metadata, whatever the configuration is. So whatever it is there with respect to how the cluster is looking right now, that information is stored in etcd, and it is in the form of a key value distributed form. Right, so that is what etcd is. Now we will discuss that once we get into the architecture. We'll discuss about the different components as well. Let's move on.
Alright guys, so if you like the lecture so far, we also train on Kubernetes, and it's a complete online training. For more details, you can check out the details on the screen. That will lead you to our training page where you can check out what all we teach in our Kubernetes course.
And talk about can we use many claims out of a persistent volume? Now, interesting one. So let's talk about persistent volume first. So we have various different kinds of volume mounts, right, in Kubernetes. So you can use different kinds of volumes like mtdir, or there are a lot of volumes which are possible in Kubernetes that you can mount. Now the difference between these volume mounts and the persistent volume is the simple fact that let's say we have a pod, right? So if let's say if I delete the pod, and it's a part of a deployment, so deployment keeps on respawning your pods, right? So let's say if I delete one particular pod, what happens to the information inside of it? So if it is not a persistent volume kind of volume mount, then that information will get lost. It will go somewhere. It won't respawn, right? So if you want that information to stay and persist, for that you use persistent volume. Now creating a persistent volume is different from what you create a normal volume, right? For creating a persistent volume, you need persistent volume claims. You need a storage class, and then you use the claims to mount the volume. So it is a kind of a tedious process. You have to do 2-3 different things: create a storage class, create a volume claim, and using that claim you need to mount it on your persistent volume, something like that. So the question here is asking is, how can we use many claims out of a persistent volume? So the answer is the mapping between the persistent volume claim and the persistent volume is always 1-to-1. It is you cannot use many claims out of one persistent volume. The mapping is 1-to-1. Even when you delete the claim, the persistent volume still remains as we set in the volume reclaim policy, and it will not be reused by any other claim. So the answer to the question is no. The mapping is always 1-to-1, and it is not being used by any other persistent volume claims. Move on to the next. How do you deploy a feature with zero downtime in Kubernetes? Again, interesting question. So if you are deploying a new feature, how do you ensure that there is zero downtime whenever you're doing it? The answer I think we answered this question before, that this is one of the great capabilities of Kubernetes, and the answer is you can apply a rolling update. So in Kubernetes, in the strategy, while deploying your deployments, while creating the YAML file for your deployments, you mention the update strategy in there. So if you do the update strategy in your deployments as a rolling update, in that scenario, whenever you're trying to deploy a new feature, it will do a rolling update, and that will ensure that your pod does not see any kind of a downtime. How does it do that? So let's say I have 4 different pods which are running, or the 4 replicas of the same pod, right? So I have a version 1 of 4 pods. Now what I'm trying to deploy is 4 pods of the version 2. So what it will do is it will take down, let's say, a pod 1, and all the requests which are there, like let's say 4 fingers are pointing to pod 1, 2, 3, 4, like 1 pointing to 1, 1 pointing to 2, 1 pointing to 3, 1 pointing to 4. So if any request comes based on the load balancing feature, it could either go for pod 1, pod 2, pod 3, or pod 4. As they are replicas, it shouldn't matter which one it goes to, right? So it is going to there. So whenever you are applying an update, so let's say it will take one of those pod down. It will not take all of the 4 down together. It will take one of them down, and it will stop showing it as a mapping. So where it takes one down, and instead of the one, it puts a new pod, and then it takes the second one down and it puts something else. So till your update is completely done for all of the pods, it will make sure that there is no downtime, right? So it will keep on pointing to the older pods till all of your pods are replaced. And once all of the pods are replaced, it will start rerouting the request to the new version of the pods. That is how it does that when you are doing a rolling update. Okay, so let's move on to the next question. So next question is, what is the difference between a replication controller and a replica set? So the question is pretty straightforward. First and foremost, I would want to mention that the replication controllers are obsolete now, no longer used in the newer versions. It was used in the older versions when Kubernetes came out, so you should point that out. It shows that you have information about the current situation of Kubernetes. So the replication controllers are obsolete now in the latest version of Kubernetes. There's the slight difference between replication controller and replica sets, and that slight difference is called as selectors. Replication controllers do not have selectors in their specifications or spec part of the YAML, whereas replica sets do. So this spec lets you help, this selectors helps you select different kinds of services and different things like that. Replication controller does not have it, replica set does. That's it. Okay, next question. What is a kube proxy? So with proxy, you can think that this is some kind of an alias, has to be related to network. Your mind should go there instantly. So Kube proxy runs on each of the nodes, and Kube proxy is responsible for directing the traffic to the right container based on the IP and the port number of the incoming request. So whatever the incoming request is, so let's say the outside world doesn't know what is the architecture inside, right? So they just basically click on something and the request comes. So whatever is the request, whatever the container they are asking, like this is the request, this is the particular thing which I want to talk to. So it's the job of the kube proxy to direct traffic to the right container based on whatever the requests are, and that request is based on an port number as well as the IP address. So that is how you basically do it, and that is done through kube proxy. Let's move on to the next question, and this is what is a headless service? Now, interesting question. So this question may or may not show up depending on the kind of interview you have, because headless service is not used in many organizations, to be honest. But a headless service is very much similar to a normal service. Only the thing that it does not have is the normal service, but does not have a clustered IP. So basically, this service enables you to directly reach the pods without having to go through an proxy. So you can have directly hit it with an IP address and you directly reach the service. It does not have a cluster IP. It does not have a direct IP you can reach. You have to provide a proper IP to reach it. It doesn't go through any kind of a proxy. So that is what a headless service is. Let's move on to the next one, which is explain PVC. So we talked about persistent volumes, right? So PVC basically stands for persistent volume claims. So the earlier question that we have, like how many claims that we can use, this question is about talking about what is persistent volume claims. So the full form is persistent volume claims, and it is basically the storage requested by Kubernetes for pods. It asks Kubernetes, okay, this is the volumes that I need for the storage for this particular pod. And the user does not require to know the underlying provisioning. This claim should be created in the namespace where the pod is created. So two things you have to keep in mind. Wherever your pod is, in the same namespace, you have to create your particular persistent volume claim. This is the one thing. And through persistent volume claims, you basically request for storage volume. Like this storage is required here. You ask for that and Kubernetes provides you with it. So you do that, and using claims, you can mount it in the volumes of the pod. Only thing to keep in mind, make it in the same namespace. What is a namespace? I think that question will come up later, but basically a namespace is used to segregate your cluster into different parts, so that people who are working different teams or different geological locations can divide the resources among them and address things in one place. So that is what a namespace is. So in one side of one namespace, you will have one particular set of things only, and if you do not define any kind of a namespace, everything that you create, let's say a pod service or anything else, it goes to the default namespace by default, right? So that is what it is. Let's move on to the next question. So now it is the interesting one. So tell us about the different components of the Kubernetes architecture. So as you can see in the picture below, the different components of the Kubernetes architecture, right? So as I mentioned before, we have two main components, which is a master components, which you can see the big box on the left hand side, and the node components, which is on the right hand side. There can be multiple nodes. Both of the nodes have the same architecture, if you can see, and different components are there. So in master, you can see there is an API server, there is a scheduler, there is a controller manager, there is kubectl, and on top of it, and there is etcd. So in the master node components, let's talk about the different components. So API server, it is the first point of contact for the entirety of all the REST commands, REST commands, which are basically used to manage and manipulate the cluster. So API server is the first point of contact for all of the REST commands, and it is basically used for managing and manipulating the cluster. Then you have the controller manager. Controller manager, it is a daemon that is responsible for regulating the cluster in Kubernetes and manage various other control loops which are non-terminating. So non-terminating control loops, as well as responsible for regulating the cluster in Kubernetes. Then there is a scheduler, which, as the name suggests, is responsible for scheduling tasks on the worker node, and it keeps the resources utilization data for each of the slaves nodes. So whenever you have a new service or new pods or everything which is spawning, it's the job of the scheduler to make sure it spawns on which node, and it does that based on the your resource utilization, resource ability, and different things like that, and keeps the track of all of the resources which is used in all of the different nodes, and it takes a judgment call based on that as to which node should be given this particular task. So that is the job of the scheduler. Then you have etcd. We discussed about etcd a while back. So basically it is a distributed key value storage where you have shared configuration. It is also used for service discovery as well, and it stores all of the information about the current situation of what your cluster looks like. So that is what etcd is. And that we have some components on the worker node, which you can see. There is kubelet, there's a docker container, there is Proxy, and there is pods. The Docker container, and could be any other container also, in my opinion, but Docker container are most widely used, so that's why it's mentioned Docker container. So Docker container must be initialized and run on each worker node in a cluster. Docker containers run on each and every worker node, and they also run on the pods that they are configured, right? So that is what it is. Then there is Kubelet. So we discussed about kubelets. The job of the kubelet is to get the configuration of the pods from the API server. So API server has all of the details. It gets it from there, and then it ensures that whatever the containers are mentioned and whatever the specification is mentioned on the API servers, it makes sure that everything is running according to that. So that is the job of the kubelet. Then there is Proxy, which we also discussed. So Proxy behaves like a network proxy, and as well as the load balancer for a service on any single worker node, and basically it helps to direct traffic to the particular proper node, particular container which the request is coming based on the IP as well as the port number. So that is the job of kubelet. And then there are pods. A pod can be thought of the most basic execution unit of Kubernetes. It can have one or more containers which can logically run on different nodes altogether. So these are the different components of Kubernetes architecture, right? So with that, let's move on to the next question. So this is a scenario-based question. If you have to pass sensitive information in your cluster, how would you do it? And by sensitive information, we generally mean, like, let's say you have username, you have password and something like that. So how do you pass that to your cluster without, making it vulnerable to any kinds of attacks? How do you do that? So Kubernetes has this very good feature called as secrets. So we can pass the sensitive information in Kubernetes using secrets. Now secrets can be created through YAML files. You can have that in your YAML defined, or you can create it through text files as well. And majority of the organizations in the world will be using secrets to pass on information. You can utilize environment variables and whatnot to bring it from here and there, manipulate it and everything like that. So you can use that in order to pass on the sensitive information with respect to your cluster. Let's move on to the next question, which is, what is a Sematext Docker agent? So basically, this is something which is there present in Docker. So it is basically a log collection agent with event and metrics. It runs as a small container in each of the Docker hosts. So in each of the Docker hosts, it runs, and these agents basically are there to gather metrics, events, logs for all clusters and nodes and containers. So again, another feature which is there for storing information with respect to logs, metrics, and different events which are out there, and it is basically used for that. Let's move on to the next question. If you delete a pod which is created as a part of deployment, what happens to the information inside of it? Well, the answer to this question also we discussed earlier on. So if the volume mounts which you have used inside of the pod of any other form rather than persistent volume, then it is almost obvious that your data will get lost, right? Your data will be deleted, it will be lost somewhere if you delete the pod having information which does not have volume mounts which is persistent volume. If you want the data to be retained, then in that scenario you have to create, a storage class, make a persistent volume claim and use that claim in one of the pods as a persistent volume. Mount your information in your persistent volumes. In that scenario, what happens is, let's say if my deployment has three pods so far, has three replicas, 1, 2, 3, and it's, let's say pod 2 has the information which is required, and pod 2 gets deleted for some reason, so it will respawn a new pod. Let's say the new pod is pod 4. So now we have still 3 pods running, but the pod names are 1, 3 and 4. So in that scenario, the pod 4 which is respawned will have the information which is required, and this is coming from the persistent volume. So that is the basic idea behind it. So let's move on to the next question, which is question number 19. Is there any pattern to pods being assigned to different nodes? Can you make sure a pod gets scheduled on a particular node? So to answer this question, you can start off like the initial assignment of the pods. A pod can be assigned to any node. It depends on the scheduler where it wants to do it, and depends on the resources and the requirements. It totally depends on the scheduler. So it could, let's say if I have 6 node, if I spawn it the first time, it could be gone to the 6th node. Next time it could be pod 3rd node. It could be some other node. But let's say if there was a requirement where I wanted to run a pod, but I wanted to this pod required the services of a very good GPU, and only one of the nodes have that good GPU. So how do you make sure that the pod goes and attaches itself to that particular node? It can be done through something called as taints and toleration. So you can add a taint to your particular pod, and you can have a particular node which can tolerate those taints. So you can add that taints and tolerations, and if you do that, the pod will not go and assign itself to any other pod. It will only go and assign itself on those nodes which can tolerate the taints. So that is the way you can basically make sure your pod goes and gets assigned to one particular node, right? So that's how you do it. Next question, which is let's say Kubernetes job should be finished in 20 seconds. So we create a job which should be finished in 20 seconds. However, sometimes it takes like 5 minutes to do it. How can I make sure to stop the application if it exceeds more than 40 seconds? So a normal job is created which has to be done in 20 seconds. Generally it gets done in 20 seconds, but due to some scenarios it takes 5 minutes. So whenever it takes 5 minutes, we have to make sure that that does not happen, and the maximum allowed time for the process to run is 40 seconds. So how do you avoid that? It is very simple. You only have to add one particular instruction in your YAML of while creating the cron job or whatever the job that you are creating. Whenever you are creating that in the YAML file, you need to provide the specification of -- active deadline seconds flag equal to whatever the number of seconds that you need. Whenever you do that, it basically relates to the duration of the job. So once it reaches the particular threshold specified by the flag, the job will be terminated. So if the condition here is 40 seconds, then -- active deadline seconds equal to 40. That's it. All you have to do is that, and it will make sure that after 40 seconds, your job gets terminated. So these were the interview question, guys. So with that, we have come to the end of the Q&A questions of interview questions. So how to get started is the next question. So if you are someone who is just starting for Kubernetes, or you want to get more in-depth knowledge about different things, what I would recommend is that we at Intellipaat, we always believe that an investment in knowledge always pays the best interest. That's why we provide a lot of free content in the form of blogs as well as a YouTube tutorial. So if you are an avid reader, go check out our blogs about various different technologies. Or if you want to watch out different long tutorials, we have tutorials up to 7, 8, 9, 10, 11 hours on different technologies. You can check them out on our YouTube channel as well. But if you're someone who's looking for job assistance and you want to learn with the experts, you want some live instructor to take your doubts, teach you everything, and have a curriculum where you can perform different assignments, do hands-on, do quizzes, as well as create projects, then I would recommend you to check out our website, which is intellipaat.com. You can search for various different courses that we offer, and you can enroll with us, and we'll be happy to assist you with respect to that. So with that, we have come to the end of this session on Kubernetes interview questions. If you have any questions regarding this session, you can keep them down in the comment section below. And if you have any other queries, you can reach out to the numbers mentioned on the screen, or you can write to us at support@intellipaat.com. So with that, I've come to the end of this session, guys. Thank you so much for watching, and I will see you in the next one.
Alright guys, so if you like the lecture so far, we also train on Kubernetes and it's a complete online training. For more details, you can check out the details on the screen. That will lead you to our training page where you can check out what all we teach in our Kubernetes course.